I'm Herb Gross, and welcome to lecture number 3 of Gateways to Algebra, where today we're going to introduce the topic called sign numbers. Now, before I do that, I thought I'd like to give you a more general mini lecture on what the scientific method is and what the growth of civilization indicates. Because I think if you see these things in the proper context, you learn a lot more than just the math itself. See, what happens with the scientific method, let me see if we can illustrate this in terms of a fairly simple diagram. What you have is people are moving along at a certain plateau, things are going on okay, and they get stuck at something. Now they have a choice of staying stagnated down here or trying to invent something that gets them, as the expression goes, over the hump. So somebody comes along with an innovative idea, and all of a sudden there's a jump, and you reach this new level. And from this new level, you can look down at the old level and see things that you could never see before from this height. That's the good news. The bad news is that from this level, you can deduce or experience a problem that people at this level never even knew existed. And so the cycle continues. You hit a bump, you get over the hump, get to a new level. From the new level, you can see all kinds of things that you couldn't see before, but all of a sudden obstacles come that you never even knew existed. It doesn't just apply to math, it applies to life itself. You know, people say, boy, when we get rid of cancer and heart disease, maybe we'll live forever. But the possibility is what? That one of the reasons we haven't seen certain diseases is we haven't lived long enough to get them. After heart disease, after cancer, after AIDS, who knows what lies next? In other words, in a certain sense, infinity from a practical point means that no matter how far we advance, there will always be a new plateau that we have to overcome. And what's happened in a very simple form in this class here, that just the command that says pick a number and subtract it from something has led us to a situation that we haven't dealt with before. And to deal with that situation, we're going to have to invent something new. And the thing that we're going to invent is going to be something called sign numbers. But again, what's interesting is that when we invent things, they're not often completely brand new. Very often, they're an extension of something that we've already known before. And to get into that, let me bring up a topic that comes up very, very early in the mathematics curriculum, and it leads to the subject called division. And it's a subject called rates. To recognize a rate, it'll always be two nouns separated by the word per. The nouns can be anything. You can put miles here or apples here. You can put hours here, lawyers here. It doesn't matter what you put in. See, this would be called what? Miles per hour. Apples per lawyer. And this is called the rate. The reason being that whenever you see a rate, it's going to tell you how fast something happens. See, let's take, for example, miles per hour. Suppose a person says to me, boy, did I travel fast. I say, how fast did you travel? He says, I went 100 miles. So what? What if it took 15 weeks to go that 100 miles? It's not telling you how fast, that's only how far. Or suppose another person says, gee, I didn't go very far. I says, how far did you go? He says, I only went 2 minutes. Well, 2 minutes is time, not distance. What if you were traveling 1,000 miles a minute? 2 minutes would be 2,000 miles. So you see, to understand how fast you're traveling, it's not enough to know how far. It's not enough to know how long. You have to take what? The ratio, hence the word rate of the two. So for example, if a person went 100 miles and it took 2 hours, we would take the 100 miles, divide by 2, and that would be called what? An average of 50 miles per hour. You see, the real problem is that there are many times in life when you're more interested in how fast than you are in how much. Let me give you a hypothetical situation. You're driving your car, and just as luck would have it, you stall on a railroad track. You look, and you see a train a half mile away, and that train is moving 120 miles per hour. See, if that train was stopped, you wouldn't have a problem. See, that 120 miles per hour is scary. See, it's not how far away the train is, it's how fast it's moving. Okay? But it is moving 120 miles per hour. It's a half a mile from you. How much time do you have to get out of the car? And by the way, before you start calculating how many miles at 120 miles per hour, how long it's going to take you to travel a half a mile, let me give you another piece of information that I left out. I forgot to tell you that the train was traveling in this direction. You see, what happens is, not only is the rate important, but is the rate making the train get closer to me, or is it making it get further away from me? Because it's important to understand the difference. See, rates are important, but what's also important is what? A rate can be viewed as an adjective that modifies either what? An increase or a decrease. I just want to make sure we understand that. Okay? A rate may increase, or a rate may decrease, or a rate may remain the same. And that's called a constant rate. What's an example of a constant rate? A constant rate would be when you're buying cheese at $2 a pound. Every time you buy one more pound of cheese, okay, it's costing you $2 more. It's $2 for each pound. What's another constant rate? There are 12 inches in a foot. For every foot that you have, you multiply that by 12 to get the number of inches. That's called the constant rate. On the other hand, suppose you're buying apples by the pound. If you buy 5 apples for $1, that may not be a constant rate because it depends on the size of the apples. See, if the apples have different sizes, 5 apples for $1 simply tells you on the average you spend 20 cents an apple. One of the apples might have cost you 15 cents, another apple might have cost you 45 cents. So you see, the idea is what? Rates may be constant or not constant. They may either vary by increasing or by decreasing. And what that does is it means we have to have more vocabulary. So what we do is we say this. If a rate increases, we use the word positive to denote it. See, positive 3, when we're referring to a rate, means it's an increase of 3. And the way we write it is we take what looks like a plus sign. And be very, very careful here. It looks like a plus sign, but we don't read it as plus. We read it as positive. And I'll explain why later in this lesson. So positive 3 means what? An increase of 3. In a similar way, we always think of what? The opposite of positive would be negative. Negative 3 says what? Negative 3 says a decrease of 3. So if I say that my speed was negative 3, it means I'm decreasing by 3 units. If I say it's positive 3, it's increasing by 3 units. And if I say 0, that simply means no change. By the way, this is an algebra course, meaning math course, not a language course. So we don't want to talk about increasing and decreasing, positive and negative. Those are words. We want to start using what? Numerical amounts. In other words, if we're going to call constant rate 0, in other words, change is 0, then we want to refer to what? Increase would mean more than 0. Decrease would mean less than 0. Let's just review that to make sure you understand that. And that's simply an agreement. See, the real important thing is that whatever positive 3 denotes, negative 3 must be just the opposite. But the agreement is that positive will go with increasing, and since 0 is no change at all, increasing means you're doing more than 0, so positive 3 means 3 more than 0, and that's another way of saying that in the sign number, which is made up of the sign, which is either positive or negative, and the size, the magnitude, which in this case is 3, the magnitude part tells you the adjective, see the 3, and the positive and negative sign tells you what that adjective modifies. See, positive 3 and negative 3 both indicate a change of 3, but the positive sign means what? Increasing. Negative sign means decreasing. So when you see positive 3, it's understood to mean what? 3 more than 0. When you see negative 3, it means what? 3 less than 0. And to make sure that you understand this, in this context, 0 is not the same as nothing. 0 simply means what? No change at all. See, in other words, you can have something moving at a constant rate, and 0 simply means no change. Again, let me review the vocabulary over here for you. Here's this number that we read as what? Negative 3. The noun is the sign. In this case, negative. The adjective is the amount. When you look at negative 3, the size part tells you that the 3 tells you that the adjective is 3. The sign tells you that the 3 is modifying less than 0. And again, what happens in math is the vocabulary part. And very frequently, the vocabulary is more difficult than the concept. You see, here's negative 3 again. And what did we say? 3 is called the magnitude. See, that's already a big word. See, adjective was simpler. Or the absolute value of negative 3. See, the absolute value is the size. See, the positive or negative just tells you whether it's increasing or decreasing. The amount comes from the adjective. And to make the mathematics even more complicated, we usually abbreviate it. When we want to talk about the magnitude, you see, we take the number and we put 2 vertical lines. We surround it with that, and those are called absolute value signs. And the way you read this is the absolute value of negative 3, and all that means is 3 itself. In other words, the absolute value of a signed number is the magnitude itself. And let's just practice with that a little bit more. If I say, what's the absolute value of negative 5? How do you read what's inside the absolute value sign? It's 5 less than 0. It's a decrease of 5. What's the adjective? It's the 5. The amount is 5. All the negative part tells you is that it's decreasing. What's the absolute value of positive 5? This is what? An increase of 5. The adjective is still 5. Another way to think of this is a blue pencil doesn't look like a blue shirt. But the adjective blue means the same thing in both cases. See, an increase of 2 is different than a decrease of 2, but the 2 is the same in both cases. You see, you don't want to confuse negative 2 with positive 2. They're different. Why? Because an increase is different than a decrease. But the adjective part is the same. Okay? And in terms of a number line, it looks something like this. Suppose I draw a line over here. Here's what I mean by saying 0 doesn't mean nothing. 0 is going to be the starting point, the no change point. And moving in this direction is going to be increasing. So I locate the point P 5 units to the right of the point O, and I locate the point Q 5 units to the left of the point O. Now, both of these points are how far from O? They're both 5 units. If I say, show me a point that's 5 units from O, the answer is going to be what? P or Q. However, what's the difference between them? P is 5 units in the positive direction from O. Q is 5 units in the negative direction from O. So the way we read this is what? P would be indicated by being called what? Positive 5 to tell us what? That the change is 5, but in the positive direction, to the right. Q is called negative 5 because Q is also 5 units from O, 0, but in what direction? To the left. Okay? By the way, one more agreement that I want to share with you. When a number appears without a sign, it is assumed that the number is positive. For example, 5 and positive 5 mean the same thing. And by the way, can you see why? If I go into a store and say, can I please buy 5 apples, is it clear that I intend to take 5 apples with me and not leave 5 apples in the store? When I say I want 5 apples, why should I say positive 5 apples? It means automatically what? 5 more than nothing. In that case, none and nothing mean the same thing, but let's not worry about that either. See, when I say I want 5 apples, I want what? 5 more than none. Okay? So why bother writing the positive in that case? And so the agreement is what? Whenever you're dealing with signed numbers, all right, and you don't see a sign, it always means positive. And by the way, don't give any precedence or preference to positive over negative. You can't have one without the other. If I go into a store and buy 5 apples, when I leave the store, how has my apple supply changed? I have what? 5 more apples. In other words, I have positive 5 apples. How about the guy who owns the store? He has 5 less apples, doesn't he? So if I look at this exchange from my framework, the transaction was positive 5. If I look at it from his framework, it was negative 5. So positive and negative, which is which, depends only on the frame of reference, but what you have to remember is what? Whichever one you call positive, the other one will be called negative, okay? So I'm just trying again to get you used to the vocabulary that we use over here. Well, positive and negative numbers by themselves can be very interesting, but like any other system that we've done so far in arithmetic, what's the sense of knowing numbers if we don't know how to do computations with them? It's great to understand what fractions are, but if you can't add them, you can't subtract them, You can't multiply them. You can't divide them. What are you going to do with them? So you see, like in any game, once you know the names of the pieces that you're playing with, you have to be able to do what? Tell what rules govern them. You see, you can't even begin to tell people the rules of a chess game until people know what the pieces mean. How do you tell a person how a pawn moves if a person doesn't know what a pawn is? So you see, first you start with the equipment, and in this case it's signed numbers, and now we have to tell you how we combine those pieces into winning strategies, and in this case it's going to be what? How you do the arithmetic of signed numbers. So let's again review something that I think is very important. I always love to use this example because whenever people are afraid of math and I walk into the room, they're afraid of this guy who used to be at MIT. He's supposed to be real good at math. So the first thing I do is I write down 3 plus 2 is 40. And what do they say? Thank God he's one of us. They don't say, isn't he brilliant? Does this look right to you? It shouldn't the way it stands. However, what I wanted to emphasize, and I've already used that term in this lesson, is numbers are what? Adjectives that modify nouns. So suppose next to the 3, I put down dimes. Next to the 2, I put down nickels. And next to the 40, I put down cents. Is this all of a sudden a true statement? Is 3 dimes plus 2 nickels 40 cents? But you see, if I erase the nouns, then you see the adjectives don't look like they're doing the right job. So in other words, the only time that 3 plus 2 is 5 is when 3, 2, and 5 are adjectives that modify the same noun. Okay? So knowing that, let's see how we're now going to add signed numbers. Suppose I say to you, how much is positive 3 plus positive 2? And this is why I don't want you to confuse positive and plus. Positive will always refer to the sign of a signed number. Plus will always mean you're going to add. So when you say positive 3 plus positive 2, it means you're doing what? Adding an increase of 3 to an increase of 2. Notice how strange it would sound to say plus 3 plus plus 2. See how this language helps you that way? By the way, some traditional textbooks prefer to write the positive sign the same size as the plus sign, and then they encompass the whole thing in parentheses to indicate what? Everything inside the parentheses is one number, so a signed number is what? A magnitude and a sign. But how would we add positive 3 and positive 2? Let's translate what this means. Positive 3 means what? 3 more than 0. Positive 2 means 2 more than 0. Are the 3 and 2 modifying the same amount? Yes. How do you add when they modify the same amount? You add the two adjectives, in this case the magnitudes. 3 plus 2 is 5. And you keep the common denomination, the noun, which is more than 0. And how do you write that in this language? Positive 3 plus positive 2 is what? Positive 5. Okay? You follow the idea here? Positive plus positive is positive. By the way, there is an application from business that makes things easier for some people to see. Some people see things beautifully if there are dollar signs in front. In a business application, 0 stands for break even. Positive stands for profit, and negative stands for loss. So positive 3 plus positive 2 simply means what? A $3 profit followed by a $2 profit. Written this way, the 3 and the 2 modify the same noun, so we add them and keep the common denomination. And if that bothers you in terms of adjectives and nouns, draw a bookkeeping ledger. Positive 3 means what? A $3 profit, so we put it in the profit column. Positive 2 means a $2 profit, so we put it in the profit column. Here are 2 numbers in the profit column. How do you total these 2 transactions? You simply do what? They're in the same column, so add the adjectives and put the answer in the common column. Same thing would happen if both numbers were negative. Let me see if I can separate these 2 little things here. Here's negative 3 plus negative 2. What does negative 3 mean? It means a $3 loss. What does negative 2 mean? It means a $2 loss. $3 loss plus a $2 loss is what? The adjectives are modifying the same noun. It's a $5 loss. It's that simple. In terms of the diagram, the 3 is in the loss column, the 2 is in the loss column. So we total it by doing what? Adding up the 2 losses and putting the answer in the loss column. Of course, the tougher thing is what happens if they don't have the same sign. See, what if you have positive 2 plus negative 3? Let's stick with the profit and loss thing for the time being, because I think it's easier for you to understand that. This says what? You have a $2 profit and a $3 loss. Why can't you add the 2 and the 3 now? Because they're modifying different nouns. For the same reason, you couldn't add the 2 and the 3 when the 2 was modifying nickels and the 3 was modifying dimes. So we say, let's look at the business application. How would we handle this? The $2 profit, the 2 goes in this column. The $3 loss, the 3 goes in this column. What do we do now? Don't we look at the difference? We don't say let's subtract the profit from the loss or the loss from the profit. We say what? Let's subtract the smaller transaction from the greater transaction. 2 is smaller than 3, so I'll subtract the 2 from the 3. That gives me what? 2 from 3 is 1. I put the answer where? In the column with the greater transaction. 3 is more than 2, so the answer goes over here. In other words, what's positive 2 plus negative 3? It's negative 1. A $2 profit followed by a $3 loss is a $1 loss. Okay? And by the way, if we reverse these, and it was a $2 loss followed by a $3 profit, all we would do is what? Put the 2 in the loss column, the 3 in the profit column. We would still do what? Subtract the 2 from the 3. We never subtract a bigger amount, a bigger magnitude from a smaller magnitude. You always do what when they're in opposite columns? Subtract the smaller magnitude from the greater. It's still going to be what? 3 minus 2 is 1. That hasn't changed, but now the answer goes where? In the column where the greater transaction is. That happens to be the profit column this time. So a $2 loss followed by a $3 profit is a $1 profit. Now, the thing about mathematics is we don't like to talk about profit and loss because there can be other forms of increasing and decreasing. So what we do is, using the profit and loss as a model, we summarize this more abstractly. We say, look, what did we do to add 2 signed numbers? If the numbers had the same sign, we added them and kept a common sign. If they had different signs, we subtracted the smaller magnitude from the greater and kept the sign of the greater. In other words, all this says is what? Mechanically, it says what? To add 2 signed numbers, case 1, the numbers have the same sign. Step A, add their magnitudes. Step B, keep the common size. Case 2, the numbers have different signs. Subtract the lesser magnitude from the greater. Step 2, keep the sign of the number with the greater magnitude. Now, do you see how complicated that can become if you're memorizing it? You say, my gosh, how am I supposed to remember that? The way you remember it is think in terms of profit and loss, or think in terms of increasing and decreasing. Think in terms of to the left and to the right. Whatever model fits your mind, think of it that way, but state it abstractly so that whenever you're dealing with increasing and decreasing, you can use the same laws of arithmetic no matter which model is being obeyed. By the way, there is one more thing I do want to point out, and that is that under this definition, we haven't told you what to do if you're dealing with 0. The thing I want you to note is that the role of 0 as the additive identity remains the same even when you're dealing with negative numbers. In other words, what was the rule about 0 before? When you added it onto a number, it didn't change, that number. The thing is still true. In other words, negative 6 plus 0 is still negative 6. And in terms of profit and loss, all it says is if the first transaction is a $6 loss, and the second transaction was you broke even, the net result is you still have a $6 loss. And to close today's lesson, I want to do one more thing, and that is to show you again the gradual way in which mathematics builds up. I have shown you how to add and subtract 2 signed numbers. Person says, what if I'm given a whole bunch of them to do? What am I going to do here? Well, didn't we always say you can always add numbers by 2 at a time? Could I start with negative 3 and add positive 7? See, by my rules, negative 3 plus positive 7, I subtract the smaller magnitude from the greater. 3 from 7 is 4. Keep the sign of the greater magnitude, that's positive. Then what am I going to do next? Combine the positive 4 and the negative 2. And when I'm through with that, I'm going to combine that answer with the positive 5, that answer with the 3, that with the negative 12. And in fact, in terms of a profit and loss scale, all we're saying is what? Here's a $3 loss, a $7 profit, a $2 loss, $5 profit, $3 profit, $12 loss. You can do it any way you want. You can, for example, do what? Add up all the profits, add up all the losses. Look at just these 2 transactions, a $15 profit, $17 loss. Subtract the 15 from the 17, put the answer in the column with the greater magnitude. So all of these transactions combine into what? A $2 loss. In other words, the answer to the problem that we just did, the answer to this problem is simply what? -2. Okay? And by the way, we're going to close now, but I just want you to notice that this idea of doing things in pairs always works. How can you tell in a group of people who is the tallest? How can you line them up according to height, only looking at 2 people at a time? All you have to do to find the shortest guy is to compare the first guy with the second. Whichever one is shorter, keep him. Now compare him with the next one. Whichever one is shorter, keep that one. And keep on going until you get through the whole list. The survivor is the shortest person. Now do the same process with the ones who are left, which is exactly what a computer does, only much faster. And all I want you to see is, again, the beauty of how we solve complicated mathematics problems by reducing them to what? A series of simpler but equivalent problems. That's all we're going to do for today. Next time we're going to talk about what? After addition comes subtraction. We're going to talk about subtracting sign numbers. But until next time, again, study hard, enjoy yourself, stay young.